Dear students, in this video, I am going to discuss the economic schedule. The economic schedule problem or the optimal schedule problem or optimum generation scheduling. So it is the optimum generation scheduling considering losses. Considering losses. In previous videos, I discussed the economic schedule problem without considering losses. Now the economic schedule problem considering losses. So generally in the transmission system, so the losses will be from 5 to 15% of total load. Therefore, losses have to be included in developing the economic dispatch policy. So here the objective is to reduce the overall cost of generation. So the cost function is C equal to I equal to 1 to K CI of PZI. So this is the cost function. What is the objective? So to reduce the cost of generation at any time and under equality constraint. So what is the equality constraint? It is nothing but the power balance equation. So that means PZI minus PD minus PL equal to 0. So this is called the equality constraint or power balance equation. So here the objective function is to minimize the cost with equality constraint that generation should be equal to demand plus losses. Demand plus losses. So here K is number of plants, the total number of plants. What is number of plants? What is PZI? It is the generation of ith plant. PD is the total load demand. PL is total transmission loss. So again, to solve this again, there are number of methods are there. So one of the easiest method is method of Lagrangian. So here we define the Lagrangian multiplier as sigma of I equal to 1 to K CI of PZI, CI of PZI minus lambda into this equality constraint. What is equality constraint? I equal to 1 to K PZI minus PD minus PL. So like this, we define the Lagrangian. So for optimum power dispatch, for optimum power dispatch. So this Lagrangian, the first partial derivative of Lagrangian with respect to PZI should be equal to 0. Should be equal to 0. So we take the first partial derivative of this multiplier with respect to PZI. Then what this equation will become? DCI by dPZI minus lambda plus this transmission loss is function of power generation. So minus lambda minus into minus plus lambda into dou PL by dou PCI. Dou PL by dou PCI. So this is first partial derivative of Lagrangian with respect to PCI and it should be equal to 0. So now here what is take common lambda. So then DCI by dPZI, DCI by dPZI equal to lambda into 1 minus dou PL by dou PCI. 1 minus dou PL by dou PCI. So this is the equation after simplifying we will get. Or in other words, this what is this DCI by dPZI? It is called the incremental cost of ith plant. incremental cost of ith plant, that equal to lambda into 1 minus ITL. What is this ITL? It is called the incremental transmission loss. It is called incremental transmission loss. And this second equation is called the coordination equation. So the incremental cost of ith plant equal to lambda into 1 minus ITL. What is this ITL? ITL is called the incremental transmission loss, that equal to dou PL by dou PCI. Dou PL by dou PCI. So here, we discuss the coordination equation. In other words, we write the same equation, that is dCi by dPgi equal to lambda into 1 minus dou PL by dou PCI we got. So this we can write it as dCi by dPgi by 1 minus dou PL by dou PCI. 1 minus dou PL by dou PCI equal to lambda. Or in other words, dCi by dPgi into Li equal to lambda, where Li is called the penalty factor of ith plant. Penalty factor of ith plant. What is this Li? Li equal to penalty factor of ith plant. And what is this penalty factor? 1 by 1 minus dou PL by dou PCI. So dou PL by dou PCI is called incremental transmission loss. 1 by 1 minus incremental transmission loss is called the penalty factor. So this is the equation. This is the equation which represents the economic operating schedule considering losses. That means when the product of the incremental cost of ith plant and penalty factor of ith plant equal to lambda, or the product of incremental fuel cost and penalty factor equal to same for all the plants, then economic operating schedule can be achieved. Economic operating schedule can be achieved. Suppose there are two plants are there. There are two plants. Then what is economic operating schedule considering losses? DC1 by DPZ1 into L1 equal to DC2 by DPZ2 into L2, that equal to lambda. What is this DC1 by DPZ1? Incremental cost of first plant into penalty factor of first plant equal to incremental fuel cost of second plant into penalty factor of second plant. When both are equal, the economic operating schedule can be achieved. So here the lambda is expressed in rupees per megawatt hour. Rupees per megawatt hour when fuel cost, that is C, that is fuel cost is given in rupees per hour. When fuel cost is given in rupees per hour, lambda will be rupees per megawatt hour. Suppose fuel cost is given in dollar per hour, then lambda will be expressed in dollar per megawatt hour. So here, what is the conclusion? When we consider losses, the economic operating schedule can be achieved when the product of the incremental fuel cost and penalty factor of each plant is same. Each plant is same. So here, and one other important thing is how to determine the transmission loss. How to determine the transmission loss. So this transmission loss can be calculated again in a number of methods. One of the method is by using the B coefficients. One of the method is by using B coefficients or loss coefficients. B coefficients or loss coefficients. So when we use these B coefficients, the transmission loss can be represented as the transmission loss equal to sigma of m equal to 1 to k, sigma of n equal to 1 to k, PGM into BMN PZN. So this is the generalized formula for transmission loss in terms of loss coefficient, where this PGM, PZN are real power generation at M and nth plants. BMN is called the loss coefficient. If we express the PZ, that is the real power generation in megawatt, the loss coefficients will be expressed in reciprocal of megawatt. That is one important thing. So what is unit of loss coefficient? Reciprocal of megawatt. When we express the power generation in megawatt, then loss coefficients will be expressed in reciprocal of megawatt. And the other important thing is BMN equal to BN. That means suppose B12, you know B12, then B12 will be equal to B21. So in matrix form, this transmission loss can be expressed as PL equal to PZ transpose B into PZ. B into PZ. So this PZ equal to, suppose there are k number of plants are there, then PZ equal to PZ1, PZ2, like that up to PZK. And what is this B? B equal to B11, B12, B1K, B21, B22, B2K. Like that, BK1, BK2, BKK. So this B matrix is a symmetric matrix. B matrix is a symmetric matrix. That's why BMN equal to BNM, because it is symmetric matrix. BMN equal to BNM. Suppose it is there is a two plant system. Then what is transmission loss? PL equal to PG1 square B11, PG1 square B11 plus PG2 square B22 plus 2 PZ1 PZ2 B12. So this is transmission loss for a two plant system. So in the next video, I will discuss some numerical examples based on this concept.